Good morning, class. We are looking at Module 3 practice test or exam review covering from section 5.4, right triangles, all the way to chapter 8, application of trigonometry. All right, in this example, we want to find CD. Given the information, this is 18 degrees, this is 200, this is 36 degrees, this is 90 degrees, and there are different ways of approaching that. So we want to find CD. Notice this is a straight angle, 180 degrees. Therefore, the angle ABD is 180 minus 36, makes it 144 degrees. So this is 144 because they add up to 180 degrees. Angle BDA is 18 degrees. Why is that? Because this is 144, this is 18. And if you add them up and subtract 1 from 180, this becomes also 18 degrees. That's the reason. So again, the interior angles for this one, 180, so 18 plus 144 subtracted from 180 gives you 18 degrees. Therefore, since AB is 200, BD is also 200. Why is that? We have the same angles. That means we have an isosceles triangle, and they must have the same side. So we found this is 200, this is 200, 18 degrees, 144 degrees. Now we're going to use this small triangle, BCD, and sine of 36 degrees, this angle, is the opposite, which is the CD, over the hypotenuse, which is BD, and we are going to plug in BD equals 200. Therefore, CD is the product of a sine of 36 degrees and 200. Using a calculator gives us what we were looking for. We were looking for the value for CD, 117.557 feet. We are assuming those are in feet. If they are not, just without the units. We want to solve the right triangle. Remember, solving means we want all sides, all angles. A is 8, B is 2, C is 90 degrees. So that's what we have. We have two sides, and we use Pythagorean theorem, a squared plus b squared equals c squared. So a squared plus b squared equals c squared. Let's just write it. A squared plus b squared is c squared. And this is 64. This is 4. We get 68. And therefore, c is the square root of 68. And 68 is the product of 4 and 17. 4 comes out as 2. This is the precise answer. And this is an approximation with a couple of decimals. Now, this angle tan of this angle is the opposite B over the adjacent A. So this is C. So this is the opposite B over the adjacent A. 2 over 8 or 1/4. So B is the tan inverse of that. Using a calculator, we end up with 125 radians or 14.03. And so all we have to do is subtract this from 90 degrees to find A. And we can write out the whole thing. A, B, C, lowercase a, lowercase B, lowercase c. Could somebody read this, please?
A girl is standing 20 feet in front of the Disneyland Christmas tree. The star at the top of the tree to the bottom of her shoes make a 60-degree angle. How tall is the tree? What is the distance between the girl and the star? Draw a diagram.
Excellent. So it looks something like this. We draw this diagram. This is what is the distance between the girl and the star. So this is what we are looking for. This is 60 degrees. We are writing all the information, we're putting in all the information. This distance is 20 feet. And this height, we call it X. So tan of 60 is the opposite. X over 20. Therefore, X is the product of these two. 20 times tan of 60. And using a calculator, of course, tan of 60 is square root of 3. It's a common arc. And with a couple of decimals, this X becomes 34.64. This is a 90-degree angle. A squared plus B squared equals C squared. Pythagorean theorem. So we can find that C squared is 20 squared plus X squared, which we have it to be 3464 quantity squared. We plug it into a calculator. We take a root, and I hope you realize it's almost 1600. So the root is almost 40 feet. By the way, this is not the only way you could use a, let's say, sine of 60 degree, which is opposite, which we found it to be 3464 over the hypotenuse, and find it because sine of 60 is square root of 3 over 2, or cosine of 60, which is 20 over c, and find it. So there are other ways to find that. Pythagorean theorem is one of them. Again, we have a triangle, and we want to find a few missing information, like one side AC is missing and two angles. Angle A and angle B are missing. As you can see, by the way, this is lowercase a, this is lowercase c. So we can see that this is a side angle. We are going to use the sine law. Sine A over A equals sine B over B equals sine C over C. Since these two are known, we can say sine of this side 67 degrees over this side 8. It's sine of A over this side because it's given as 5. And therefore, sine A is the product of these two. divided by 8. That's a cross product. By now, we've done it many times. You should have no problem with that. So sine A is 5 times sine 67 over 8. You use a calculator at this point. And you find the sine A, and the angle A is the inverse sine. So whatever this number is, the inverse sine gives you 35.1 degrees. Since this is 67 degrees, we can add it to 35.1 and subtract it from 180 to find the missing B. So this is A. Subtract the sum from 180, and it gives you 77.9 degrees. This is the last angle. And now we continue with the sine law. And we say, again, this thing that we had, sine of 67 over 8. This time, sine of 77.9 degrees over the missing AC or lowercase b. AC is the lowercase b. So this is 102.1 and it gives you 77.9. So now plug in AC or lowercase b becomes 8 times sine of 77.9 divided by sine of 67. And again, using a calculator gives us the AC being 8.5, meaning we got all the missing we were looking for. So we got the AC, we got the angle A, we got the angle B. Everything is known now. Very straightforward, everybody. Now, I'm going to look at more triangles, and this is the concept of a side angle, which we normally use as sine law. And there are 3 cases. This is known as an ambiguous case. I'm reminding you, where H becomes B sine A. If A is less than H, there is no angle. There is no triangle. In this case, when H is less than A less than B, we have 2 of them. And if H is B sine A, we have one of them, which is a 90-degree angle or a right triangle. So here's the case where 2 sides are given, A and B, and 1 angle. So we can plug in. So we make this up. Capital A represents the angle 50. Across from it is lowercase a cos 3, and it may not be to scale when we do the drawing. Lowercase b is 2, and we want to find the rest of it. So we can use the sine law and write the general form. We can say sine of 50 over 3, sine of a b over 2, sine of a c over AB or lowercase c. We write this in general. And what we have this part, and therefore we can find the B. So let's use these 2 fractions and do the cross product to get to sine B. So sine B is 2 sine 50 degrees over 3. And using a calculator, we can find sine B to be 0.511. And using the inverse sine, we find this to be 30.7 degrees. Now, why are we calling it case 1? Because, as you know, sine is positive in the first and the second quadrant. So there is one more possibility for this, and that would be 180 minus this number. So case 2, B is 180 minus this number. Again, I want to make sure that we understand how we arrive at it. 180 minus 30.7 gives us the second. We're going to work on both cases. So let's finish up the first case. So the first case, we have 30.7 degrees, we have 50 degrees, we add them up and subtract from 180. So 30.7 plus 50, so that gives us 80.7. In other words, this is a 180 minus the sum of angles A and B, which is 180 minus 80.7 degrees. So if we want to continue with the sine law, now we're going to use this part because we have the capital C, so sine of 99.3 degrees. And we're going to use it with this part. So sine 50 over 3 equals sine 99.3 over lowercase c. C is the product of these two, 3 times sine 99.3 divided by sine of 50. And C becomes 3.86. If you want, I can write this for you. So from here, C is 3 sine of 99.3 over sine of 50. We have this, and let's write all of them just to give you the whole picture. So capital A is 50. We found B to be 30.7 degrees. We found C to be 99.3 degrees. A was given to be 3, B was given to be 2, and lowercase c was found to be 3.86. So this is case 1. What about case 2? That is not possible. Why is that? Because when you add this one with 50, the sum is more than 180. So there is no way to find the third angle. So whenever the sum of this and this is more than 180, that does not work. So again, case 2 doesn't work simply because the sum of these two is more than 180 degrees. There is no more triangle. So one case will do the job in this example. Now we have a case where A, B, C, that means all sides are given. We want to find the missing angles. So this is a side angle, which uses side, which uses cosine law. And here's the sine law, here's the cosine law. A squared is B squared plus C squared minus 2BC cosine A. And remember, Pythagorean theorem is a special case of that. If you change this to 90 degrees, this goes to 0 and it becomes Pythagorean theorem. And with that, we can find cosine A by moving this piece to the right, a squared to the right, this minus 2bc cosine a to the left, a squared to the right, and then divide by 2bc. So this is what we have, and we're going to use that formula because we want to find capital A. So b squared plus c squared minus a squared, just plug in. So b squared 9, c squared 36 minus a squared 64 over 2bc, and we end up with negative 19 over 36. So what is a cosine inverse of this number? And it ends up being 121.86 degrees. At this point, you can use the cosine law or the sine law to find the next angle. So let's continue with the cosine law and using this formula, but this time, this was cosine A, we're going to change this to cosine B, which means this becomes 2AC, and these two change places. This becomes a squared plus c squared minus b squared. So think about this, change this to b, and this is what happens. So you should be able to make this transition. We're going to plug in. A squared is 64. C squared is 36 minus b squared is 9. The denominator is 2 times 8 times 6. So we get 91 over 96. And b is the cosine inverse of that, which gives us 18.57 degrees. So if this is 18.57 degrees, this is 121.86 degrees. Add them up, subtract from 180. We get 39.57 degrees. So again, remember, they must add up to 180 degrees. You have two of them. Subtract the sum from 180. So we can quickly write that this is 180 minus A plus B. And just plug. Very straightforward. Two angles are given. One side is given. So clearly, we are going to find the third missing angle because the sum must be 180. So let's do the drawing. This is 95, this is 45. So this must be, add these two, subtract from 180. So that's 40 degrees. That's very simple. So we got this to be 40 degrees. The sum of these two must be subtracted from 180. Now we can use the sine law, for example. Sine of 95 over 5, because we have this, we must go with that, is sine of 40 over A, sine of 45 over B. That's what we are going to use. So sine 40 over A, the cross product, 5 times sine 40 divided by sine 95 gives you A. 5 times sine 40 over sine 95, and you plug it into a calculator. We write the same thing, but this time sine of 45 over B. So B is the product of these two, 5 sine 45 divided by sine of 95. Again, using a calculator will give us the answer. And let's write the whole thing. We found A to be 40, B was 45, C was 95. Those were given. We found lowercase a, lowercase b, and C was given as 5. As far as the number of decimals you use, you should always read very carefully and see what they ask you to do. So we have the missing signs. Now, in this case, again, 2 angles are given with one side angle, angle. So this is 55, this is 20, and therefore this can be found by adding them up, subtracting from 180 degrees. So we have all angles. We have one side, we use the sine law. For example, sine of 55 over 4 equals sine of 105 over AC, which is lowercase b. B is the cross product of these two divided by sine of 55. And using a calculator, we can come up with the answer. So this was the cross product. Use the same thing, sine 55 over 4, and then sine of 20 over C, or we can use sine of 105 over 4.717. I'm going to use the new one, but my recommendation is always to use the old one because of what's given. So again, I use that. The reason being, if for any reason we made a mistake here, then the result will be wrong here. So stick with the given. So rather than using that, I would suggest you use this one. I just wanted to show you it can be used, but use this one instead of that. So again, the cross product will result in C being the product of 4.717 and sine 20 over sine of 105. And now we have everything. We can write them in order. Capital ABC, lowercase ABC, and all sides and all angles are given. I'm going to use the law of cosine to prove this. Cosine A over A plus cosine B over B plus cosine C over C is A squared plus B squared plus C squared over 2ABC. We remember the sine law, the cosine law, and with the cosine law, we say cosine is B squared plus C squared minus A squared over 2BC. So what we do, we start with one side. For example, we start with the left-hand side, and we take a common denominator of ABC. So if we take a common denominator, LCD would be ABC. So this would be cosine A times B times C. This would be cosine B times A times C. This would be cosine C times A times B, and we put those first. For example, for cosine A, we would write BC cosine A. We write them in this sketch. Now, we are going to compare this to this. Notice, if I put the BC up here, let me just quickly do that for this one, because I want you to notice this. as I'm looking at this one, I notice this means BC cosine A is B squared plus C squared minus A squared over 2. So that means I can replace BC cosine A with this. So I can replace this one with this. And when I do that, that creates 2 down here. Because when I do that for this one, let's see what happens now, compare and contrast. BC cosine A is this, right? AC cosine B is A squared plus C squared minus B squared over 2. And AB cosine C is A squared plus B squared minus C squared over 2. So when we put those in the numerator, this as this and this and that, they all have a common denominator of 2. So you can put that as the denominator part of ABC. So if I put all of those at top, this becomes a complex fraction. So I hope you can see that I can put this 1 over 2, this 1 over 2, this 1 over 2, and I bring the 2 down here. So what happens? Let's go with B squared and minus B squared. This one is left. C squared minus C squared. This one is left. Minus A is a different color. Minus A squared and A squared. This one is left. And that is the right-hand side. That's a proof. Would somebody read this, please?
An aircraft is spotted by 2 observers who are 1,000 feet apart. As the airplane passes over the line joining team, each observer takes a sighting of angle of elevation to the plane, as indicated in the figure. How high is the plane?
Thank you so much. So to the plane was repeated. All right. So let's see what happens as we look at the drawing. We notice here's the angle of elevation from one side. This is from another side. And so we can figure out quickly what's going on by calling this H, calling this Y, and this angle, add these two, subtract from 180. So the angle of P or Q, 35 and 40, 75 minus, when you subtract it from 180, so you get 180 minus 40 plus 35, and that's Y, it's 105 degrees. In other words, we have all the angles. So in the big triangle, we have all the angles and we have this side. So we can find all sides. And the side we are interested in, let's find Y by saying sine of 105 over 1,000 is sine of 35 over the missing PR or Y. By the way, those angles are 50 and 55, simply because this is 90 degrees, this is 40 and 50. This is 35, must be 55 subtracted from it. So we have those. First, let's calculate this. And Y is 1000 times sine 35 over sine of 105. So Y or PR is about 593.81 feet. How high is the plane? We are interested in this height, everybody. We want the H. So we can use this triangle, this left side, which is a right triangle, and say sine of 40 is the opposite, which is H, over the hypotenuse Y, which we have it now to be this number. And therefore, H is the product of sine of 40 and 593.81. And that's about 381.69 feet. Could somebody read this, please? I appreciate it, class. Everybody can be involved. Go ahead and somebody read for us. The sooner you read, the sooner we'll be done today. Go ahead, somebody read it, please.
Two homes are located on the opposite side of a small hill. To measure the distance between them, a surveyor walks the distance of 50 feet from house P to point R, uses a transit to measure angle PRQ, which is found to be 80 degrees, and then walks to house Q, a distance of 60 feet. How far apart are the houses? Draw a diagram.
So we have a situation like this, and we are interested in finding the distance between the two. One is located at point P, one is located at point Q. So we draw this. We call them P, Q, R, and this distance that is of interest to us is X. So this is 50 feet. This is, when we turn 80 degrees, this is 60 feet. This is 80 degrees. And it looks something like this. PQR, 50 feet, 60 feet, 80 degrees. So we are interested in finding the value for this distance, PQ, or we call it X. So it's side, angle, side. As you can see, we have both sides and the included angle. So we're going to use the cosine law. A squared is b squared plus c squared minus 2bc cosine a. Therefore, PQ squared is 50 squared plus 60 squared minus 2 times 50 times 60 times cosine of 80 degrees. Which means now you just plug it into a calculator. You come up with PQ squared. You take a root, and PQ, the distance between the two, is about 71.12 feet. 71.12 feet, the distance between the two houses. Would somebody read this, please? Nobody feels like reading? Wow. One more time. Anybody want to help us? Read the question, please.
Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One boat has traveled 300 feet and the second has traveled 350 feet. How far are these boats apart? Draw a diagram.
Perfect. So one is going this way, one is going that way, and we call them A, B, C. One has gone 300 feet, one has gone 350 feet, while they make 135 degrees between the two, and we are interested in the distance of a BC or A. So we have cosine law here because side angle side is the included angle. Cosine law says A squared is B squared plus C squared minus 2BC cosine A. Therefore, A squared is 300 squared plus 350 squared minus 2 times the product of these two numbers times the cosine of 135 degrees. Cosine. We plug it into a calculator. By the way, 135 degrees is a common arc. For 45 degrees, cosine is squared of 2 over 2. For 135 is negative of that. And that gives us this answer. We take a root of that, and A becomes 600.83 feet. It's about 601 roughly, the distance between the two. Right now, it's a little bit over 600 feet. Two cars leave an intersection together, traveling on courses with an angle of 45 degrees between them. If each travels 500 feet, if each travels 500 feet, how far apart are they? Well, one is going this way, one is going that way, making a 45-degree angle in between, and each one covers 500 feet. So again, we can use the cosine law. We are interested in this distance. Again, this may not be to scale. So A squared is B squared plus C squared minus 2BC cosine A. If you want to use C squared equals A squared plus B squared minus 2AB cosine theta, that's just as good. And so basically 500 squared plus 500 squared minus 2 times the product of these two times cosine of 45 degrees. And at this point, you just put it into a calculator, and there are a couple of steps in between. You can find this, take a root, and C becomes 382.68 feet. The distance between the two is a little bit more than 382 feet. We have a similar situation, but this time the two cars that they leave the intersection, they make an angle of 30 degrees. One goes about 1,000 feet and the other one 720 feet. How far apart are they? Again, let's do the drawing. So one is going this way, one is going this way. In between, there's a 30-degree angle. And again, not necessary to scale. One is going about 1,000 feet, one is going about 720 feet, and we are interested in the distance between the two using the cosine law. So basically, 1,000 squared plus 720 squared minus 2 times the product of the two times cosine of 30 degrees. And again, you plug it into a calculator, you do the math, you take a root, and C becomes 520.89, roughly 521 feet. But again, however many decimals they ask you. George is standing 35 feet in front of a house and notices that the angle of elevation from eye level to the top of the house is 60 degrees. Find the height of the house. Well, reminding you of the concept of angle of elevation. So here's the horizontal line. If you're looking up, creates the angle of elevation. If you're looking down, it creates an angle of depression. So just reminding you of that. So we are standing here this way. This creates the angle of interest, which is the angle of elevation of 60 degrees. So this is 60 degrees. We are interested in finding this height when we know this distance is 35 feet. So this is, everything is about the diagram. If we can come up with that, it makes it very simple. Right now, I hope everybody can see the tan of 60 degrees is the opposite h over the adjacent 35. And so h is the product of tan of 60 and 35. And tan of 60 is square root of 3, and it becomes 60.62 feet, almost 61 feet. So it's a very simple process if we do this right. George is standing 27 feet in front of a house on a hill and notices that the angle of depression from eye level, the top of the house to its bottom, is 73 degrees. Find the height of the house, draw a diagram. So first and foremost, again, angle of elevation versus the depression, we want to see what's going on. So take a look at what happens here. So standing here, this is the angle of interest, angle of depression, which is 73 degrees. We are interested in finding this height when we know this distance is 27 feet. So again, this is a right triangle. Therefore, tan of this angle is the opposite, which is h, over the adjacent, which is 27, and we can find the missing h by doing the cross product. H is 27 times tangent of 73 degrees. Using a calculator gives us 88.31 feet. 88.31 feet roughly. So again, drawing a proper diagram really makes it easy to understand what's going on. Anybody want to read this one?
A balloon is flying at a height of 600 feet, directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram.
Thanks. And reminding everybody that 1 mile is 5,280 feet because we are using different units. We have to go with the same, so we need to have this piece of information. So this is how it looks like. The balloon right at top, 600 feet is the height. This distance is 5 miles. Here's the angle of depression. And as you can see, these two angles are the same because you have two parallel lines and a traversal. Therefore, the alternate interior angles are identical. So if I can find this one, it's the same as this one. And therefore, tan of theta is the opposite over the adjacent, 600 feet over 5 miles. So we change this to 5 times 5,280 feet. And it gives us 0.0227272. I used a lot of decimals. So this is the answer to that. And theta is tan inverse of that. So this becomes this. Theta is the tan inverse. So it's almost 1 degree. So 1.302 degrees. That's the angle of depression at that point. Anybody want to read this one for us? A rocket takes off a bearing of north 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? Draw a diagram. Well, first and foremost, reminding everybody about this and how the bearing is given. For example, this one would be north 30 degrees east. This would be north 70 degrees west. And this one, which is not given, is south 20 degrees east. So as an example. So north 30 degree east actually is the same as this one, right? So we are going this way for about 900 meters. So we're going this way 900 meters. Then we're going to turn 90 degrees towards northwest this way. It's a 90-degree angle. This is a 90-degree angle. And we're going to go for about 1,000 meters, which creates this line. What is the new bearing of the plane? Draw a diagram, which means if you call this alpha, this angle, the answer is north alpha west. So take a look at this one, north alpha west. So all we have to do, come up with the value of alpha. So if this angle is theta, tan of theta is the opposite, which is 1,000, over the adjacent, which is 900, 10 over 9. So theta is tan inverse of 10 over 9. So this angle is 48.01 degrees. We know this was 30 degrees. That means this was 30 degrees. If we subtract 30 from that, gives us the alpha. So 48.01 subtract 30. Why 30? When we were going this way, it was north 30 degrees east, north 30 degrees east. So we know this angle is 30 degrees. Let me use a different color to show that. So this one is 30 degrees, subtracted 18.01, and that's the final answer. It's all about understanding the problem and being able to come up with its diagram. Could somebody read this, please? I have a couple of questions, class. Read this, please.
An aircraft flees an airport from a runway with a bearing of north 40 degrees east. After flying for half a mile, the pilot turns 90 degrees and heads towards the southeast. After flying for 1 mile in this direction, what bearing should the control tower use to locate aircraft? Draw a diagram.
Excellent. So we are going north 40 degrees east. We are going this way. So we go this way for half a mile, and that's a 40 degrees, right? Then we turn 90 degrees. This is 90 degrees. We go southeast. That's a 90-degree angle. I made it huge enough so everybody can see that. And we go for about 1 mile. And now we have this angle. We also have this angle. And if we call this alpha, we are going south, alpha east, south, alpha east. That is the answer, which means all we have to do, find alpha. Now, as you can see from north to south, it makes 180-degree angles. We have 40 degrees here. If we can find this angle, which we're going to call it theta, then we can find alpha, and that's exactly what's going to happen. So this angle is theta, and tan of theta is the opposite, which is 1 mile, over the adjacent, which is half a mile. 1/1/2 is 2, and therefore is tan inverse of 2, which is 63.43 degrees. So this is 40 degrees. Theta is 63.43. So what is alpha? Remember, the total here must be 180 from north to south, right? It's a straight angle. So add this to 40, subtract it from 180. Gives you 76.57, and therefore the answer is south, 76.57 degrees east. All right, let's switch gears, plot the points in polar coordinates, -2, 0. And as you can see, we start, this is r, theta. So first, reminding everyone, this is the polar axis. This is located at P, P with X, Y, or r, theta. So the polar is r, theta, and that's X, Y. And therefore, this one is simply 0 degrees -2. So -2, 0 is located in this format. So 0 degrees, and because r is -2, in the opposite direction. 1 pi over 2, remember this is 0, this is pi over 2, this is pi, this is 3 pi over 2. So you go pi over 2, and you go 1 tick mark. Find other polar coordinates when we have the point with coordinates 1, pi over 2, and we want theta to be between 0 and -2 pi. All we have to do is subtract. Remember, let's just write the general form. If it's r theta, I can add 2k pi, because this is not unique. There are infinitely many ways of representing that. So I can add 2 pi or multiples of that, 2k pi, k is an integer. Or if I want to make this negative, I just add a pi, or when we write pi plus 2k pi, that means odd multiples of pi. So I want r to be positive, but I want this to be negative, so I'm going to subtract 2 pi. I want R to be negative, so I'm going to put this -1. But I still want this to be positive, so just I add a pi to pi over 2. I want R to be positive, so that means I'm going to use the same one. But between 2 pi and 4 pi, so just add 2 pi, it gives you a number larger than 2 pi, which means a complete revolution plus pi over 2. That's really the meaning of it. It's very straightforward. Plot the points first, then find their coordinates. Part A, find the rectangular coordinates for this case, 6 and 150 degrees. First, with the case of polar, you go with R, comma, theta. You come up with theta and then R. So in this case, you go 150 degrees, and then you go 6 tick marks. One, two, three, four, five, 6. That's the location. Now, polar has coordinates r theta, rectangular has coordinates x comma y, where x is r cosine theta and y is r sine theta. So let's plug in. 6 cosine of pi over 6, remember cosine of 5 pi over 6 is the same as pi over 6, but in the second quadrant is negative. Remember, cosine of pi over 6 is the square root of 3 over 2, but the reason it's negative because it's in the second quadrant. 6 and 2 cancel each other, 3, so makes it negative 3 square root of 3. Y is r sine theta. Now, sine of 5 pi over 6 is the same as pi over 6, but it's still positive because in the second quadrant, sine is positive. So sine of pi over 6 is 1/2, so 3. And therefore, this pair with coordinates r comma theta is the same as this pair with coordinates x comma y. We want to find the polar coordinates for x comma y 2 comma -2. So let's locate that. To go from rectangular to polar, first we need to calculate r. So x squared plus y squared is r squared. As you know, this is 2 squared, which is 4, minus 2 squared, which is 4, 8. And the square root of 8 is 2 square root of 2. I'm assuming everybody knows square root of 8 is 2 square root of 2. Now we want to come up with theta, and theta is tan of theta is y over x minus 2 over 2 makes it negative 1, and theta becomes negative pi over 4. Therefore, this pair can be written as 2 square root of 2 comma minus pi over 4. And if we want a positive angle, we just add a 2 pi. Okay, so this is negative pi over 4. This is 7 pi over 4. So add 2 pi and it gives you the same result. We are practically done. I just wanted to remind you about 2 parallel lines and the creation of 8 angles. And as you can see, the angles that have the same color, they are equal. And they are called corresponding angles or corresponding interior angles, exterior angles. They are called alternate interior angles that are equal. Same side interior angles are supplementary. Alternate exterior angles are equal. Same side exterior angles are supplementary. That's something that everybody knows. But remember, you have 2 parallel lines and a line that cuts them diagonally. It's transversal line. So just to refresh your memory about that.